Alright, so we are going to continue our talk about exponential type formulas and functions. One of the most common used ones is what we call the compound interest formula. This will actually predict, so let me talk about what all of these things mean. So A of t is basically the account value after everything is done. Okay. T up here is the time in years that we're going to invest in something. So this is where we're going to invest a certain amount of money for a certain amount of time, and this will tell us how much we'll have at the end. Okay. So T is the time in years. So P, this P value right here, is the initial investment, or it's sometimes called the present value. Okay, so this is essentially how much we put in to start with, or at present what we have. Okay, so R is the annual percentage rate, and usually they tell us it's 2% or something like that, but we write it as a decimal. And then N is the number of times that the interest is compounded annually. So we'll talk about what those different things mean as they come up. So it means, when I say compounding, that means so every so often the bank looks at the account and says, okay, here's the interest, and they put it in the account. And then the next time the interest is calculated, the newest interest will be calculated on the principal plus the interest before. So that's why we call it compounding, is because the interest keeps getting added in, and then we make even more money because we have a little bit more money in our account. Okay, and N, okay, so I talked about N is the number of times it's compounded annually. So for instance, if it was compounded just annually once a year, like simple interest sometimes is, it's just like in our case, N would be 1. If it's compounded quarterly, then N would be 4. If it's compounded monthly, then N would be 12. If it's compounded daily, then N would be 365. Okay, and so on. So let's come to our first question and how we use it. So if we invest $5,000 in an account paying 4% interest compounded monthly, how much would be in the account after 10 years? Okay, so let's figure out what all of these things are. So we're going to use this formula up here. Okay, and so based upon this, our 5,000 is our initial investment here of P. Okay, so that's where our 5,000 goes. Let me just rewrite it up here. So our compound interest formula is A of t equals P times 1 plus R over N to the NT. Okay, so that's just rewritten so I don't have to keep going back up. So I realize that 5,000 is my P. Now what I want to find is A of t, because that's what I want at the end, is how much I'll have after a certain amount of years, 10 years. So the rest is just 1 plus, then my rate here is 4%, right? So I take my 4, I essentially divide it by 100 to get 0.04 is my rate as a decimal. Okay, so essentially what that does whenever I divide by 100 is move that decimal place back 2 places. Okay, if you don't believe me, play with it. Alright, so it's compounded monthly, so in our case, N equals 12. There's 12 months in a year, so that becomes our 12 is our N, and then raised to the N times T, our N is 12, and our T, this is in years, so we're good to go. Be careful, because sometimes the book likes to say, oh, 6 months, right? And T is always in years, so that means my T would be 1/2 in that case, because 6 months would be half of a year. Alright, so 12 times then our 10. Alright, now you should play with putting this into your calculator. If you have one of the bigger calculators like a TI-83 or 84, you just put it in just like this, all in one step. If you have one of those smaller calculators, like a TI-30, you're going to have to practice putting them in a little bit. What I recommend is, if you're putting it into a smaller calculator, is to actually put this part in first, right? Hit enter, and then raise it to this power. Be very careful. Like, I could have just written 12 by 10 here, which is 120. I could have replaced it. But if I'm going to make my calculator do that for me, then I need to put parentheses around my 12 times 10. Otherwise, it'll raise to the power of 12, and then multiply by the 10. So this exponent should be in parentheses when you put it in your calculator, or just do the calculation and just raise it to that power. So I would put in 1 plus 0.04 over 12, right? Hit enter if I was in the small calculator, raise that to the 120th power, and then multiply that by 5,000. When you do, you should get $7,454.16. I rounded it to the nearest cent because that's what we do in money, okay? So we don't round any further than that. And so I can't say it enough. Make sure that you can get this number, okay? So make sure you practice putting it in your calculator so you can get out that number. So after 10 years, your $5,000 becomes $7,454.16. Okay? All right. So the next question I have then is what happens if we so let's say your parents want to invest, right, for your future. And we're going to put that money in a 529 plan. That's basically a plan that invests money for college, and it's interest free. Okay, and so we want to know how much we would need to put in an account today. Let's say you're just an infant right now, and your parents want to save $40,000 by the time you turn 18, so that you're ready to go to college. So at least you have some money to start off. I know $40,000 doesn't go as far as it used to, but we're going to try this out. Okay, so what would we need to invest today at 5% compounded quarterly to have $40,000 in an account 18 years from today? Okay, so this time we have a little bit different. So let me bring this back over here again. So this is our interest formula. This time, this 40,000 is the future balance that we want to have. So that is our A of T. So this time we want to know our initial investment here, P. Okay? So let me put the 40,000 over here. And then this is equal to, I don't know what P is. That's my whole goal of figuring it out. And then I have 1 plus my rate as a decimal is 0.05. And then compounded quarterly means 4 times a year. There's basically, if we divide our year into 4 pieces, right, then there's 4 months, right, or 4 different times. 4 times 3 is 12, so it's going to be compounded 4 times. Okay, so then I have 4, because that's my n, times 18. All right, so now this time, all I want to do is solve for P. So again, if I'm going to put this in my big graphing calculator, then I just need to divide by this thing, okay? So what I want to do is just put this side, 4,000 divided by this. And then to the 4 times 18, or do the math and change that. If I put that whole thing in my calculator at once, right, if I have a big calculator, or you can calculate this, but make sure you carry lots of decimal points, like 5 or 6 decimal points, because every time you stop and round, your accuracy becomes a little less, right? So I would take and put this in my calculator, come up with a number, carry multiple decimal points, and then take 4,000 and divide by that. When I do this, I end up with $16,353.76. That's unfortunate, because that's quite a bit of money to have up front. Hopefully maybe the rates will go up and it'll be a little bit easier. So just to reiterate, my compounding, right? So if it's compounded annually, right, then my n is equal to 1. If it's compounded quarterly, then my n is 4. Monthly, 12, right? Daily, 365. And I'm sure there's probably other ones, and we'll figure them out as we go. Okay, so this is one application of exponential functions that we will continue to talk about.